So by popular demand, here's the setup for Honors question 29 in chapter 3. Okay, um, you've got a 75 meter Z. Come on, brain. You've got a 75 meter distance, and you're going to fire an arrow, and it's, come on, they tell you the magnitude of that V0 initial velocity vector is 35 meters per second, and that's all they give you. And they say, they ramble on about how there's a target in the middle or something. So, oh, okay, there's a tree branch. Okay. So in the notes yesterday, I babbled a little bit about how the range is V0 squared times the sine of twice an angle divided by G. Does that make sense? Meters per second squared. Yep, I'm going to get some distance out of that formula. This is the range. Okay? And that's very important. This is the maximum horizontal displacement when your vertical displacement equals 0. So I have shot my arrow and then it hits a target at the same level. You cannot use this range formula if you hit above or below. Okay, and I am going to ask above or below on the test, so I'd like you to use the range formula on the homework, for example, for this problem and for like a derivation, but I don't give the range formula on the test and you don't need it. Okay, I'll give enough information that you can solve it. Otherwise, there actually is enough information for you to solve it otherwise. However, that requires like an epic feat of geometry and trig, which if you had online trig, fourth quarter last time, then let's not do that. We're stressed enough. Okay. But, so this is not some weird sine squared or any funny business. This is the regular old sine of twice an angle. So, they gave you the range of 75. Okay. So, you should be able to just rearrange this equation and say, like, okay, I just showed you on the previous lesson with trig that there's an inverse to every sine function. So if this sine of a twice an angle is a ratio itself, then I should be able to mash everything else together and I get capital R times G divided by this V0 squared. Okay, that's a ratio. It even has correct units of no units, right? Distance times acceleration divided by speed squared. All the meters and seconds cancel out. Okay, so I just solved the left side there. And then if I take the inverse sine of that in my calculator, I actually know what it's doing. I'm a little embarrassed. I know what it's doing when it's getting the inverse sine. You don't want to know what it's doing. Okay, your calculator knows how to get the inverse sine, and that's twice some angle, and that theta 0 angle is your starting angle right here. Okay, try it. Try doing that, and I will tell you if your answer is close enough. Okay, and you can check with your friends for exact results.